Have you ever wondered what the first human bases on Jupiter's moons would look like? Imagine the sheer vastness of Jupiter, the giant of our solar system. Its size is simply staggering, more than 2.5 times the mass of all the other planets in our solar system combined. This gas giant, with its swirling clouds and powerful storms, commands our attention and respect. But it's not just Jupiter's enormity that makes it significant. Orbiting around this colossal planet are a staggering 67 known moons, each with its unique characteristics and potential. These moons, from icy Europa to volcanic Io, represent a vast array of environments that could hold the key to future human habitation in space. As we ponder about these celestial bodies, the question arises, could these moons support human life? Can we envision a future where humans set up bases on these distant moons? As we gaze upon the giant Jupiter, we can't help but wonder about the potential it holds for future human exploration. Out of the 79 known moons of Jupiter, 4 stand out: the Galilean moons. Named after their discoverer, Galileo Galilei, these moons are unique in their own ways. First up is Io, the most volcanically active body in our solar system. It's covered in sulfur and sulfur dioxide, which gives it a yellow, orange, and white surface. But hold your horses. The extreme volcanic activity and lack of water make it a less than ideal home for us. Next, we have Europa, the smallest of the lot. But don't let its size fool you. Beneath its icy surface lies a vast ocean, twice the volume of all Earth's oceans combined. Scientists believe this ocean could harbor life, making Europa a tantalizing destination for future human exploration. Now let's move on to Ganymede, the largest moon in the solar system. It's even bigger than the planet Mercury. Its diverse surface with dark and light regions hints at a complex geologic history. Ganymede is the only moon known to have its own magnetic field, suggesting it has a molten core. But what's truly exciting is the possibility of an underground saltwater ocean, another potential cradle for life. Last but not least, we have Callisto, the most heavily cratered object in the solar system. Its surface is about 4 billion years old, a witness to the history of our solar system. But despite its rugged surface, Callisto might also hide a subsurface ocean, although not as promising as those of Europa or Ganymede. The Galilean moons, each unique and fascinating, are more than just celestial bodies orbiting the gas giant. They represent the potential for human exploration and habitation. They offer us a glimpse into the vastness and diversity of our solar system and beckon us to venture beyond our home planet. Among these moons, Europa and Ganymede hold the most promise for human habitation. And who knows, one day these moons might just become our next frontier. Europa, a moon that holds immense potential for human colonization. Let's embark on a journey to the smallest of the 4 Galilean moons orbiting Jupiter, Europa. This icy celestial body, nearly a quarter the size of Earth, stands as a beacon of hope in our quest for interplanetary habitation. Its ice-covered surface, a canvas of cracks and fissures, holds a promise of life beyond our home planet. The surface of Europa, a sprawling expanse of ice, is unlike anything we've seen in our solar system. It's a frozen wonderland, reflecting sunlight in a dazzling array of blues and whites, a sight that would leave anyone awe-inspired. But it's what's beneath this icy exterior that truly piques our curiosity. Scientists believe that under Europa's icy shell, there's a vast ocean. Yes, you heard it right, an ocean. Bigger than all of Earth's combined. This ocean, warmed by the tidal forces of Jupiter's immense gravity, could be a cradle for life as we know it. The possibility of liquid water, one of life's essential ingredients, makes Europa a tantalizing prospect for exploration and potential colonization. However, the presence of an ocean isn't the only thing that makes Europa a candidate for human habitation. The ice covering Europa could also provide a source of water for future settlers. This water could be used for drinking, growing plants, and even creating breathable air. It could also be split into hydrogen and oxygen, providing fuel for rockets, making Europa not just a destination, but a pit stop for further space exploration. Imagine setting up a base on this icy moon, living and working on the frontier of human knowledge and experience, pushing the boundaries of what's possible. The potential for scientific discovery is immense. From understanding the limits of life in our solar system to the development of new technologies necessary for human habitation in such extreme conditions. The possibility of water beneath Europa's icy surface makes it a prime candidate for future human exploration. The dream of a human base on Jupiter's moons may still be a long way off, But with Europa, it seems less like a dream and more like a future waiting to unfold. Ganymede, the largest moon in our solar system and a world of possibilities. Ganymede, one of Jupiter's many moons, holds a unique position in our solar system. Not only is it the largest moon in our cosmic neighborhood, but it also outshines even the planet Mercury in size. Imagine that! A moon larger than a planet. This gives Ganymede a substantial gravitational pull, much more than any other moon around Jupiter, and even some of the planets. But size isn't the only thing that makes Ganymede stand out. Scientists believe that beneath its icy surface, there lies a vast ocean of liquid water. This subsurface ocean, if confirmed, could hold more than twice the amount of water found on Earth. Now, think about the possibilities that this could offer for life as we know it. Where there is water, there could be life, at least as per our understanding. But the surprises of Ganymede don't stop at a potential underwater ocean. This moon also has its own magnetic field, a rare feature for a moon. Just like Earth's magnetic field protects us from solar radiation, Ganymede's magnetic field could offer similar protection. This is particularly important when considering human habitation. It could provide a safe environment for future astronauts, protecting them from the harmful radiation of space. As we delve deeper into the mysteries of the cosmos, Ganymede continues to stand as a beacon of possibilities. A moon with a magnetic field, an underwater ocean, and a size that rivals that of a planet, Ganymede could be the answer to our quest for space colonization. So, as we gaze at the night sky, dreaming of what's beyond our world, we might just be looking at our future home. A home that's not on another planet, but on a moon. A moon unlike any other. With its unique features, Ganymede presents an intriguing opportunity for future human habitation. However, colonizing Jupiter's moons is not without challenges. As we turn our gaze towards these celestial bodies, we must grapple with a host of obstacles that stand between us and the establishment of human bases on these distant moons. First, we must reckon with the sheer distance. Jupiter is, on average, a staggering 385 million miles away from Earth. Even at the speed of light, a signal takes over 35 minutes to travel from Jupiter to Earth. This means that real-time communication is impossible, and any colony would need to be largely self-sufficient. Next, we confront the harsh environment of Jupiter's moons. The surface conditions on these moons are nothing short of extreme, with temperatures that can plunge to minus 150 degrees Celsius, and atmospheres composed mainly of carbon dioxide and sulfur dioxide. These conditions are inhospitable to human life and would require advanced technology to mitigate. Then, there's the issue of radiation. Jupiter has an incredibly strong magnetic field that traps charged particles, creating intense radiation belts. Prolonged exposure to such radiation would be lethal to humans. Therefore, any habitation on Jupiter's moons would need to include robust radiation shielding. Lastly, we face the need for advanced technology. To survive on Jupiter's moons, we would need technology capable of generating power, recycling waste, and producing food in an alien environment. We would also need advanced propulsion systems to get us there and back, and to transport supplies. All these challenges may seem insurmountable, but they also highlight the ingenuity and resilience of the human spirit. We have always been explorers, pushing the boundaries of what is known and venturing into the unknown. The challenges of colonizing Jupiter's moons are just the next frontier in our ongoing quest for knowledge and discovery. These challenges, though formidable, do not diminish our curiosity and our desire to explore these distant moons. Our journey into space continues, driven by our innate desire to understand the universe and our place within it. As we look to the future, the possibility of human habitation on Jupiter's moons remains a fascinating prospect. The key to unlocking this potential lies in our ongoing research and future plans for exploration. Imagine a future where our descendants have established thriving colonies on these celestial bodies, harnessing the unique resources each moon offers. The icy moon Europa, with its vast subsurface ocean, could become a hub for hydroponic farming, feeding the inhabitants of these far-flung colonies. Ganymede, the largest moon, might house massive research facilities dedicated to understanding the universe's deepest mysteries. Simultaneously, we're developing technology capable of withstanding harsh environments and utilizing resources in situ, a concept known as in situ resource utilization. This approach could transform the way we establish bases on these moons, making them more sustainable and less dependent on Earth. The future holds exciting possibilities, and perhaps one day we will see the first human bases on Jupiter.